You're fine. Today's learning target is I can find linear and angular velocity. Okay, I can find linear and angular velocity. That's what we're doing here today. The first problem that I want to kind of draw your attention to is the one in green up here. It's referring to the Ferris wheel that's down at, I guess I was reading it was Six Flags in St. Louis. It's called the Colossus Ferris wheel, one of the largest in the United States. It has a diameter of 165 feet. Okay, so this Ferris wheel has a diameter of 165 feet, and while you're on that Ferris wheel, you are traveling 10 miles per hour. Okay, you are traveling 10 miles per hour while you are on a Ferris wheel. Now everyone knows a Ferris wheel doesn't go really, really fast. Okay, but what I'm telling you is while you are on it, you are traveling 10 miles per hour, and I want you to be able to figure out. It says find the number of revolutions per minute that the wheel makes. That's kind of our goal here by the end of class, is to be able to answer a question similar to that. Okay? So, if you are working that, save yourself a little bit of space to do the work for that problem. I'm going to teach a little bit about linear and angular velocity first, and then we'll come back and we'll answer that question. Okay? All right. So, I'm going to use just a different example to help teach linear and angular velocity before we go back to the Ferris wheel question. Okay? So this one says find the angular velocity and the linear velocity of a ball rolling 8 revolutions per second. Now let me talk about those things. First of all, I'll start with linear velocity because I think you guys know that. 10 miles per hour, that's a linear velocity. Okay? 8 meters per second, that's a linear velocity. When you hear 60 miles per hour, what do you think of?
60 miles per hour.
Okay? Yes, say it.
A car.
A car, why?
Drive.
That's what you see on your speedometer as you're driving down the road, right? Okay? Now, okay, pay close attention. A car driving down the road is traveling kind of in a line, right? A distance. Okay? 60 miles per hour is a linear velocity. Alright? So a linear velocity is what you typically think of when you think of velocity. Something traveling along horizontally usually, okay, but sure you could talk about things, you know, traveling vertically or things like that too, but you're traveling in a line. Alright, linear velocity is what you typically think of as a normal velocity. Angular velocity is different, okay? Here's an example. If I make my arm complete one revolution, one circle. If I complete one circle in a second, my angular velocity would be 2 pi radians per second. Because by going one circle around, that's 360 degrees. My arm went 360 degrees in that second, right? Everybody agree with that?
Yes.
But I want it to be in radians per second. And 360 degrees is how many radians? 2 pi, right? So if my arm completes one revolution in a second, I would say that its angular velocity is 2 pi radians per second. That's how much the angle of my arm changes in that unit of time. So an angular velocity is going to be how much the angle is changing per time unit, where a linear velocity is more of like a distance, how much that changes in a certain time unit. Angular velocity versus linear velocity, do you have at least somewhat of a visual right now of the difference between those two? Okay? So if my arm completes one revolution in a second, what was its angular velocity? 2 pi, label? Radians per second. What if I get 2 revolutions in a second? 4 pi radians per second. Okay? I don't think I can get 3 times around in a second, but obviously if I could do 3 revolutions in a second, what was my angular velocity of my arm?
6 pi radians per second.
Got it?
Yeah.
Okay, angular velocity versus linear velocity. Alright, so back to this problem. We're going to have a ball that's going to roll 8 revolutions per second. let's try to envision, I don't care, golf ball, basketball, whatever, okay, a ball rolling 8 revolutions in a second. And let's assume that there is no friction, so it's not slowing down, okay? It's just going to continue to roll at 8 revolutions per second, okay? I do need one more piece of information for you to answer this question. Yep, we need the diameter. I'll just say the radius is, if we make it a basketball, the radius would be about 15 centimeters, okay? All right? So I want to know the angular velocity and the linear velocity, okay? Well, here's all we got to do. 8 revolutions per second. That's the given piece of information, right? So I'm making 8 revolutions per 1 second. I'm going to write it as a ratio, 8 revolutions per second. All I need to do is change that to radians per second. So I'm just going to do a conversion is all I'm going to do. Okay? I need to change revolutions to radians. What's the relationship between a revolution and the number of radians? 2 pi radians equals 1 revolution. So I'm going to put 1 revolution on the bottom is equal to 2 pi radians on the top. My revolutions cancel out, and now am I ready to get my answer of radians per second after I do my multiplication? Everybody sees the only labels left are radians per second. Final answer, 8 times 2 pi would be 16 pi. I just got the 1 second on the bottom, so that would be 16 pi radians per second. This would be my angular velocity right here. Okay? This is my angular velocity. Any questions on that? All these are conversions. Okay, that's all that these are. Alright, so I had a ball, it was rolling 8 revolutions every second. That means it was, the angle was changing 16 pi radians every second. Okay, so far so good? Okay, linear velocity. I want to know how fast was this ball moving in, let's just say, feet per second. Okay, so I know that the ball is making 8 revolutions per second. So I somehow need to change revolutions to feet.
We have the radius.
We have the radius, so what can I do with that?
Can't you say that 1 revolution, or
1 revolution would
is
be
15 centimeters?
go from centimeters to
1 revolution would be the circumference, right?
Yeah.
Okay, if you have,
Alright.
I was thinking
if you got a ball right here, okay? Alright, and let's just say you're on this ball right here and we roll the ball, okay, until you end up right there on the top again. So you just ride the ball the entire way around as it rolls. How far will you have traveled? The circumference, right?
Yeah.
Whatever the circumference is. So would you agree that in this case, for this basketball, 1 revolution of the basketball would be 30 pi centimeters? Because 30 pi would be your circumference.
Yeah.
If you roll the ball 1 time around, it will have gone 30 pi centimeters.
Yeah.
Remember, circumference equals pi times diameter, right? That's the formula for a circumference. If my radius is 15, my diameter would be 30, so therefore my circumference is 30 pi. So 1 revolution of this basketball, it would cover 30 pi centimeters. Good so far? Okay? So right now, my answer would be in centimeters per second, but I want to change it to feet per second. I don't know how many centimeters are in a foot, but I do know how many centimeters are in an inch.
10.
Close.
2 point something.
2.56.
Close, 2.54. There are,
Remember chemistry.
I was going to say, I think maybe from chemistry some of you might have recalled that one. 2.54 centimeters in 1 inch. And then obviously, So
12 inches and
30.
12 inches.
12 inches
Say
in
30.
1 foot, right?
Multiply top.
So now if you look, now I would have feet per second. Those are the only labels that are left. Multiply the top, multiply the bottom, divide them. If you beat me to it, tell me the answer. If you don't beat me, you're slow. About 24.7. About 24.7 feet per second. Okay? About 24.7 feet per second would be how fast this ball is rolling. This would be the linear velocity. That would be the linear velocity. Yes, no?
Yeah.
We're good? Okay? Alright. So then lastly, let's go back to the initial problem that I started class with. Okay? If you are on that Ferris wheel traveling 10 miles per hour, how many revolutions will you make in a minute? So what are we going to start with?
10 miles over 1 hour.
10 miles over 1 hour. 10 miles over 1 hour. Okay? I want to know how many revolutions per minute. So we need to change miles per hour to revolutions per minute. Help me out.
Go to feet.
Go miles to feet.
5,280.
Nice. 1 mile is 5,280 feet.
Boom.
Okay? Then what?
Let's do inches.
Well, the diameter's in feet, so I'd say we need to stay right where we're at with feet. So we should be able to change feet to what now?
Radians. Revolution.
Or revolutions. How many feet is a revolution?
Well, you have to figure out the
100, no.
No. No.
165 what?
pi.
165 pi would equal one revolution. One time around the circle was 165 pi,
Oh, yeah.
right?
Yeah.
Okay? So 165 pi feet is 1 revolution. Okay? Because that's the circumference. One time around the circle, 165 pi feet is 1 revolution. So right now I'm in revolutions per hour. I want to know how many revolutions per minute.
Then you
Drop
go
a 60.
60 on top.
We need hours on top.
Or sorry.
1 hour is 60 minutes. So now do I have revolutions per minute? Yes, I do. I'll let you guys take this one.
Get it, Dylan.
How many revolutions does this Ferris wheel make in a minute when it is constantly moving? 12. Probably not even going to be 2.
It's worth a shot.
I got it. Big number.
533.
Oh, I
1.9.
That's not even 2.
Yeah. Anybody else confirm that? 1.9? 10 times 5,280.
I got 3 different answers.
Divide by, I'm going to put that all in parentheses so it divides by all of them. 165 pi times 60.
I got 3 different answers, so I'm not sure if that's correct.
1.7.
It's probably a problem, Sam.
I got 3 different answers and none of them were right, so don't listen.
So that also tells me then, well, that a lot of you sit here and watch me write out all the work and then watch me grab a calculator and type it in. That some of you maybe should be practicing typing it into a calculator yourself so you know how to use a calculator correctly. More than likely what's going on is you're just hitting divided by 165 pi which that's gonna divide it by 165 and then take that answer and multiply it by pi.
And
If you-
times 60.
Okay, so if you're gonna do it in one step, 10 times 5,280 divided by parentheses 165 pi times 60 parentheses, because the calculator needs to know to divide it all by that. Okay, that's the way you could do it in one step if you wanted to. Okay, but so some of you probably need to practice a little bit more with the calculator in order to get those correct. All right, so that is angular velocity and linear velocity.